3 sine t. And y is equal to, and I wouldn't do this one, right? I'm just taking the answer. Y is equal to 6 cos t. What is the derivative of this parametric equation? dy dx, what will we get? So I want you to quickly work on that. I'm giving you 2 minutes. Excellent. Excellent. And when we differentiate 3 sine t, what do we get?
3 cos t.
Great. 3 cos t. Therefore, we see the coefficients can cancel out. 3 into 6 is 2, so you have a negative 2. And what's sine over cos?
Tangent, sir.
Tan. Very good. Right. Good. Even if you stopped here, that's excellent. Well, not excellent, that's very good. But of course, I would like you to be able to, when something can cancel along or go further, you have to put your mathematical minds to work. Is this clear with everyone?
Yes, sir.
Anyone else? Other things? But the final thing we're going to look at is the implicit differentiation. My tongue was slipping all night. I kept saying implicit when I wanted to say parametric. But we are finally here to implicit. Now, did anyone look at the video I sent on implicit differentiation? Quick yes or no?
So the video is in a WhatsApp group or?
Yeah, it's in the WhatsApp group.
I'm not there, sir.
Oh boy, I'll have to add you. Anyone? All right. The thing is that the implicit differentiation is quite simple. Just one important principle we have to focus on. Okay, so let me see the simplest way that I can bring this down. So when we have y is equal to 2x, what we actually do, students, when we differentiate, this is what happens. This variable y, when I differentiate y, what I actually get is dy. dy simply says I'm differentiating with respect to y. So I put dy, and if I differentiate y, I'll get 1. Isn't that so?
Yes, sir.
Good. Now, when I'm differentiating x, basically what's happening here, it's when I differentiate x, I'll get 2, and it's actually 2, and I have to write dx. This dx simply means I am differentiating with respect to x. Are you following so far?
Yes, sir.
Anyone else?
Yes, sir.
So here what happens. If I didn't show you that, right, and I said to you differentiate y is equal to 2x, you would have given me dy dx is equal to 2. Isn't that so? Isn't that what we should get?
Yes, sir.
Great. So let me show you now what. So basically why we write it like this is because we were using the principle of implicit differentiation all the time. So look at this. If I divide both sides by dx, this is what I'll end up with. dy dx is equal to 2. So basically this is where implicit differentiation comes from. Now what I'm going to do next, you have to look at it very, very carefully, because before today I never really looked at implicit differentiation in this particular light. But why implicit differentiation is important is when you get, for example, an equation that has both variables. So you might see something like square plus y squared is equal to 25. Right? You might get a function like this or an equation like this. And they ask you to find the derivative of this equation. So that would be dy dx. But if you look carefully, we have both x and y in this equation. So what we are going to do right now, let's differentiate. So each of these terms we have to differentiate. When we differentiate x squared, what will we get?
2x.
2x. And if you follow what I said before, so let's leave that as that. When we differentiate y squared, what will we get?
2y, sir.
We'll get
2y, sir.
2y, and anytime we're differentiating anything other than x, we have to put dy dx. So basically what we'll have here is anytime you see y, you differentiate it, but you make next, you put a dy. So let me show you why that's important. Let me don't force this on you. Right? Let me don't do that. So remember what I said earlier. If I differentiate x, I should put dx next to it. Remember that? This is saying I differentiate with respect to x. Is that clear with everyone?
Yes, sir.
Now, if we differentiate y, yes, we'll get 2y, and what should I put next to it?
dy, sir.
Very good, dy. Now, if we differentiate a constant, we know it will be 0. So I don't have to put anything next to 0 because it will still be 0. Agree?
Yes, sir.
Great. Now look at this part here. This is the most important part for understanding implicit differentiation. So remember what I'm asked to find is dy dx. The only way I can get dy dx now is to get rid of dx here. So to get rid of dx, I'll divide everything by dx. Divide this by dx, divide this by dx, divide this by dx. Are you following?
Yes, sir.
So what I end up with is 2x plus 2y dy dx is equal to 0. So now we can say whenever you differentiate y with respect to x, next to the y, just put dy dx. Is that clear with everyone?
Yes, sir.
Right? So whenever you're differentiating, when there's x and y in the same equation, that's what we call implicit differentiation. When you differentiate the y, make sure you put dy dx next to it. So we are not done here as yet. We are asked to find dy dx. So all we need to do now is change the subject of the formula. Can we make dy dx the subject? And if we can, how can we do that? So please tell me what to do if I want dy dx to be the subject. Come on, I just want dy dx on this side. What do I do? Come
Sir,
on, teachers, talk to me. This is changing the subject.
sir,
Yeah, go ahead.
subtract.
Yeah, so I'll have 2y dy dx is equal to minus 2x. All right, someone else. What's the next thing? I just want y dx. That's what we are looking for. So tell me what to do to make dy dx a subject.
So we will now divide. If the 2y will go across,
Divide by what?
divide by 2y.
Great. So dy dx is equal to negative 2x divided by 2y. And we divide by this 2y because this 2y is multiplying here, right? So our final answer for dy dx would be negative x over y. Remember, teachers, the first example would be the longest because I want you to see why we do what we do. I just don't like just forcing you to say whenever you differentiate y, put dy dx, right? I like to explain why. It's important. Y is equal to...
Sir, please excuse me. I didn't hear anything just now.
Yeah.
There was a
yeah.
internet connection problem.
Basically, yeah. Okay. Basically, all I did was sum up this one here. Okay. So let me reduce it a bit. I'm just reducing it just in case if anyone wanted to copy what is here before I move on. So just give me a minute or so. All right, so let me get another one and we'll go through it quick. All right, so what I want you to